Welcome to this week's midweek space news. I'm going to round up some space news articles I found this week from websites and from social media posts. Before I do that, we're on X, so if you have an X account, you can follow an @Space Startup Hub. So with that, let's get into the first article, which is on a new company called Sophia Space that I've not heard about. So let's just read this article. So Sophia Space has raised $10 million to accelerate creation of orbital computing systems, which is all the rage at the moment. Every space company seems to be working on orbital data centers. So they've raised $10 million in a seed financing round to accelerate the development of orbital computing systems. So they have a proprietary system that combines solar power generation and radiative cooling. And this uses multiple tiles that are connected into racks to provide scalable computing power in low Earth orbit. We're building the infrastructure for the next era of space-based AI and data processing. And there's a video there. I've got some clips from the video, so I'll show those later. But let's read the rest of the article first. Orbital data centers could address some of the major challenges surrounding terrestrial data centers, such as the need for land and electrical power. I've done various videos on orbiting data centers from Elon Musk and SpaceX. I've covered StarCloud recently, and I've also covered other companies like Etherflux. And this is another company that's working on orbiting data centers. So they go on to say, the tiles are connected together, the operating system is aware of all the other tiles in the system, and does things like process heat management across the tiles. It'll route around dead tiles, it'll do security patches, it'll do operating system upgrades. Sophia Space is planning to conduct an in-space demonstration of its software with an existing communications network later this year. So this system will support on-the-spot processing of imaging data collected by Earth observation satellites. Until we get to the level where we're going to be putting up our own orbital data centers, selling these as edge computers allows income to flow into the company and gets our name out there and allows us to refine things going forward, unquote. We believe that we're not in competition with terrestrial data centers, not certainly in the near term for the next 10 or 20 years, unquote. We're going where the data is, and that's where we're doing the edge computing. So this looks like the company is targeting customers who have space assets. They have imaging satellites that collect a lot of raw data, and rather than beaming down all that raw data and do the analysis on Earth, the idea is they can beam it to a data center and do the analysis in space and just beam down the key assets. If you're monitoring forest fires, it will detect a forest fire and beam down the location. Or if you're doing maritime awareness, it will find ships and track them. And that's all the information that gets beamed down to Earth. And all the processing happens in space. At least to me, that's what it looks like. We don't pay for launch costs. The client who pays for the launch costs to get everything in orbit. We collect revenue with very little spent on getting everything to orbit. So this suggests they're not providing an end-to-end service. They're just building the AI satellites, and it's up to a customer to launch them and use that system. They're just providing the physical hardware to do the AI compute in space, and they're not providing a service. So they're collaborating with Axiom Space and Armada. So that is the article. And I've got two clips from their video. The video's a lot longer and you can watch it online, but I've just clipped out a few AI renders just so we get an idea what it looks like. So if I play this here. So this is the system unfolding in space. A lot of solar panels needed to power the GPUs. That's the first clip. And then we have another clip. Bring that up. So you can see the heat radiating off. That was very sharp. But you can see the heat radiating off the GPUs and the solar panels. So that is Sophia Space. I've just heard about them. I don't know much about them. They have a website and they have some videos on the website if you want to know more. So let's move on to our second story this week. And this is an article from Payload Space. So let's read it. It's called Orbital Data, Niche Markets Give Space Solar a New Shimmer. The face of space-based solar power, or SBSP for short, is changing due to surging interest in space industry and data centers. Using space for power purposes has fundamentally changed just in the past few years. There's been a resurgence of interest in beaming power down to the ground from space. And this is from the CEO of space solar startup Overview Energy. If you're interested in this company, I've done a dedicated video on the company, so you can watch that. The article goes on to say that a number of large US tech companies are exploring space-based data centers. So they mentioned Google, SpaceX, and Blue Origin. And I'm sure there'll be others as well. So the challenge with space-based solar power, according to Payload, is the space industry is all in on space-based data centers, manufacturing in orbit, and permanent lunar installations. We've heard Elon Musk talk about moon base alpha, and obviously NASA with the Artemis program is also talking about moon bases, and so is China. The rise of these missions has expanded the customer base for space-based solar power, providing new use cases. The vision of providing power from space is to support Earth's baseline needs, and that's still alive. The article says the vision has hit some roadblocks in the last few years, but powering industry on Earth is hard, so let's get off the planet. The sun always shines in space. That's the idea underlying space-based solar power. Beaming power down from orbit can also overcome some of the congestion and transmission challenges posed by traditional power grids. I mentioned in one of my previous videos that laying down transmission lines in Texas, for instance, will take 10 years. Due to the bureaucracy, the environmental audits, and so on, lawsuits, you can be waiting a decade, and that's just for the transmission lines. Why not just collect the power in space and beam it down directly to where you need it? For instance, a data center or somewhere else. So they mentioned Etherflux, which I've also covered on this channel, and they have contracts with the Department of Defense to beam power for remote installations. And they're exploring wireless energy transmission concepts for prospective lunar settlements, which is a new idea. I've not covered that in my videos, but apparently they have some kind of agreement with Lockheed Martin. So on the moon, it says Lunar Energy System, which is part of the concept of Etherflux, is exploring with Lockheed Martin in response to a request for proposals from NASA based on their Fission Surface Power Project. So this program, if you're not familiar with it, is that the US government wants a nuclear reactor on the surface of the moon by 2030 of at least 100 kilowatts. So it looks like Lockheed Martin will be making a proposal to the US government, and this would be for a permanent nuclear fission installation on the moon. And Lockheed are tapping the expertise of Etherflux to design power transmission techniques to transmit across the lunar surface and to satellites. So it looks like the idea is, rather than lay miles and miles of transmission cable from the reactor to a habitat or an outpost, why not use some kind of optical beaming system from the reactor directly to the moon base? So that's what Lockheed is exploring with Etherflux. So it says it's leveraging the technology that we've already developed, which is sophisticated pointing, acquisition, and tracking technology to put laser beams on a precise spot and beam power through those lasers across long distances, Yaf said. So I've not covered directly optical power beaming on the moon, covered lots of other concepts that are needed for a lunar base, but perhaps I should cover optical power beaming. There's definitely some companies working on that technology, and it looks like Lockheed Martin with Etherflux will also be looking on that to beam power from a nuclear reactor, which will have to be stationed several kilometers away from a base for safety reasons. Rather than laying down cable, you can just beam it directly. I've not come across this proposal before, so it's very interesting. And it goes on to say Etherflux instead hopes to beam solar power from space to remote customers such as isolated military installations, mines, and offshore oil rigs. And they talk about politics and space agencies and projects and so on. We'll just skip past all that. So this section is on space-based solar power at a massive space scale. So they go on to say Overview, that's Overview Energy, plans to build a constellation of hundreds of thousands of satellites in geostationary orbit and beam power to a broader array of locations. So their concept is to beam power to existing solar farms. So during the night, solar farms don't produce any energy. So at most, they operate at 50% capacity, and in practice, because of weather, it's more like 20-25%. But with orbiting solar satellites, they could beam the power directly onto the solar panels, and the solar farm produces a lot more power. The idea is they're using existing solar fields as receivers for the beam power. So this is quite niche. It has a limited set of niche customers remote island communities, mines, and hyperscalers. That is like the AI data centers like Google, Microsoft, and so on. And we have this quote at the end: because of the potential use on the moon, because of the potential for orbital AI data centers, I think it could possibly be within 5 years that we see space-based solar power on Earth. So that is the article from Payload Space, which gives us an overview of where we are with space-based solar power. You get an idea of at least American companies, American space startups that are working on this idea, and possibly this could overlap with a moon base and with nuclear reactors on the moon, which is kind of a different angle that I've not really come across before. So we have a look at Etherflux, which I've covered already, so you'll find a dedicated video on Etherflux. Their idea is to collect solar power and beam it down to military outposts. You can see here some kind of military outpost, and here's the receiver. Quite a small receiver. You can power the base from space, so you don't need fuel convoys, which are subject to attack. So this is one way around it. You could also use it for mines, which are in remote locations, or oil rigs, or potentially even cargo vessels or military naval vessels, because as you can see, the receiver is quite small. And we have a picture of the team. This is Etherflux. And also we have Overview Energy, which they talk about in the article. So they're working on collecting power and beaming it to existing solar farms. And this is a picture of Overview Energy. And we have an image from their website explaining there's the sun, the sunlight. You have a whole series of satellites that collect the sunlight and then beam it down. And as you can see in the graphic, half the Earth is in darkness. So all the solar farms in darkness are generating zero power. But if you have a contract with Overview Energy, the collected solar energy can be beamed down to the solar farms and they can then generate energy at night. So that's the idea. We actually have a small clip showing their demo. This is beaming power actually from an aircraft. Amazing. But you can see it's beamed down directly onto the solar farms. And you can see they're very happy about that. It seems to be working. So they're already working on that. And we have this little clip from Etherflux. And they're working on hardware. This is apparently Mission 1 satellite. They're just unveiling it here. So there it is. There's the satellite bus. So they're going to add their technology, their beaming technology to this satellite, and it will be ready for launch as a tech demo to verify that the technology can collect energy, beam it down very precisely to a point on Earth. So that's a video from Etherflux. This is kind of a sector that's adjacent to orbiting data centers. They obviously collect a lot of solar energy, but that energy is used to power the GPUs to do the AI processing. Space-based solar power will collect the energy, but instead of using it to power AIs, that energy is then beamed down to Earth, either to AI data centers on Earth or to receivers, and then that energy goes into the power grid, the national grid. Potentially there's some applications on the moon, either orbiting satellites beaming down energy to bases, or from a nuclear reactor on the moon, which would be several kilometers from a habitat for safety reasons, and then using optical power beaming to beam the power from the reactor to the habitat, or to mining equipment or scientific equipment several kilometers away. Okay, our final story this week is on this article from European Spaceflight, and it's called ESA, that's the European Space Agency, awards contracts for lunar remote camp studies. So you can see this graphic here of a remote outpost, and there's an astronaut there. So this would not be the main base camp. This would be a scientific outpost some way away from the main base camp. Scientists, astronauts will spend a week or two here doing some exploration, some sampling, and then they go back to the main base. That's how I understand it anyway. So let's read the article. It says, the European Space Agency has awarded a pair of contracts for studies focused on lunar habitat concepts that could support future operations on the surface of the moon. A request for proposals for its Lunar Remote Camp Study initiative. So they're talking about a deployable protective unit designed to protect robotic equipment, provide essential services, and support short-duration human missions on the lunar surface. The shelters would augment the capabilities of a larger installation such as the Artemis Base Camp. The first award is to a Copenhagen-based Saga Space Architects and they're heading up a consortium that includes the exploration company and space application services, with a second contract is expected to be announced this week. So a regular viewer on my channel will be familiar with the exploration company. It's a well-funded European space setup that's working on cargo vehicles, the NIX vehicle. Space Application Services is a European space company. They're also now a partner in the Starlab commercial space station. So they are heading up the first consortium, and the second consortium will be announced this week. It goes on to say the overall budget for the two studies is quite low, and the study will examine use cases, consider available landing options, define subsystems, outline future evolutions of the crewed system, and explore communications options, including the agency's Moonlight system, which is Europe's communication system. So Moonlight is a lunar data relay network. So the article goes on to say it will provide a comprehensive roadmap for further development, including potential demonstrators. And this study will be completed at the end of 2026. So that is the article. One thing that stands out to me is that the obvious company to be involved in this hasn't been mentioned, which is Spartan Space. So I've done a dedicated video on Spartan Space previously, but I think they would be ideal for this kind of study. Perhaps they'll be in the second consortium that will be announced later. If you're not familiar with them, we have some graphics of it here, and we have a mock-up, give you an idea of the size, another render, and this is a mock-up as well. And here's another one. That is Spartan Space, and all these companies I've mentioned, I have dedicated videos on: Overview Energy, Etherflux, Spartan Space. If I were to guess which companies would be involved in the second consortium, I would guess it's probably Thales Alenia, potentially Airbus, working or partnering with Spartan Space, and maybe some other companies. That would be my guess. It's very interesting because ESA is playing a big role in the Artemis project. They're providing the multi-purpose habitat, that is the Artemis base camp. That's where the astronauts will live and work on the moon. That's being provided by the Italian Space Agency, and I think it's being built by Thales Alenia. And they're also building the Argonaut lunar lander, which can land 1.5 tons onto the lunar surface. So a large cargo lander. So anyway, that's all the news this week. Thank you for watching. My next video, which should be out Friday, will be about a large rotating space station. It's an old concept. There's a new white paper coming out in Acta Astronautica in April, and a team have studied this concept. They've done a lot of calculations, and they've even 3D printed some parts. It's quite an interesting concept for a space station. So thank you for watching, and I will see you next time.